No, sir. I think I understand all the stuff so far. Well, most of the stuff so far.
Okay. Okay, you understand. What about other people? You guys have any questions? I'm happy to like go back and discuss.
Sir, could you briefly repeat how you got half plus 1 per s squared?
Oh yeah, sure. Yeah, very good. So, I mean, I actually left it as an exercise, but I'm happy to show this. So s squared is s1 squared plus s2 squared plus s3 squared, right? Now, the thing is that S1 is equal to what? 1 over 2 S plus plus S minus, right? S2 is 1 over 2I S plus minus S minus, right? Do you agree? Because S plus minus is S1 plus minus I S2. So I'm inverting these things. So if I add these two equations, I get 2S1. If I subtract them, I get 2IS2. And that's how I get it. Okay, so, right. Now I can say, okay, what is S1 squared plus S2 squared? So I want to convert these two guys into these plus and minus operators. So this is going to be, S1 is going to be a half of 1 over 4 pi, 4I. And then I get S plus squared, S plus, and then I'm going to get S plus and then S1 squared is S plus squared. Okay, yeah. And then plus S minus. There should be a plus, it should be a minus, right? And then there will be a plus of S plus, S minus S plus. S minus S plus, and then there's a minus S minus squared. This is just the first term. And then I'm going to get plus, again, S2 squared is going to have the same coefficient for I. Oh, what the hell am I doing? All these signs will be plus. Sorry. Yeah. Why didn't anyone stop me?
প্রথমটাতে I থাকবে না মনে হয়।
Again, you're right. But yeah, instead of multiplying S1 with itself, I multiplied S1 with S2. That's what I did. এবং সেকেন্ডটাতেও I থাকবে না তাহলে, right? So it'll be minus 1/4, right, Nahi?
Yes, sir.
So it's S plus 1 squared plus S minus squared, and then there'll be minus S plus S minus minus S minus S plus. Do you agree? So that means that this thing will cancel this thing, and this thing will cancel this thing, right? Because of this minus sign. So if I now write this out, I get 2S plus minus and 2S minus plus. And so I get 1/4, and then I get 2S plus S minus plus 2S minus S plus. So I get half S plus S minus plus S minus S plus. Did I make any mistakes? It's very easy to make mistakes here. Okay, so I have S squared is going to be half S plus S minus plus S minus S plus S3 squared, okay? Now, remember the algebra that S plus S minus is 2S3. So that means that S plus S minus minus S minus S plus is 2S3. So that means that S minus S plus, this guy, is equal to S plus S minus minus 2S3. Now use this to eliminate this guy. So S squared is half S plus S minus plus S plus S minus minus 2S3. Right, and then I have plus S3 squared, right? So now if I add these two things, what do I get? I get S plus S minus, and then I have plus S3 squared, and then I have minus S3. Okay, so this is S squared. Now, S squared is going to have the same eigenvalue for all the basis states. So I can choose any state I like. And so let me just conveniently choose S squared to act on, say, S minus S, the lowest state. Okay, I take its eigenvalue, and I take S minus S. Okay, so it doesn't matter, what state I choose here, this expectation value will always be the same. Because S squared, so now if I express this, S minus S, you can do it with any other state here. You can do it with any other state. It'll just be a bit more, a bit more, there'll be a few more steps. So, but S minus acting on this thing will give me 0. So this term will drop out. So I will have this term and this term. But this term acting on S, on this thing, is just going to give me small s squared. And this term acting on this is going to give me small s. And then I'll have S minus S, S minus S. We are assuming these things are normalized. So this is, so okay, I must have made a mistake in terms of a sign in somewhere. Because S plus S minus is 2S. Because I'm getting the wrong answer. Okay, S plus S minus is plus 2S, right? So S plus S minus S minus S plus is this. So S minus S plus is, okay, that seems like correct. So S plus minus minus, that's also seems correct. Oh yeah, no, everything is fine. So S3 acting on this thing is going to give me minus S. So this will be a plus S, right? So I get, so this is going to be S squared plus S. So I get S times S plus 1. So we see that the eigenvalue, the expectation value of S squared is S plus 1, right? I mean, I didn't need this thing. This thing was not necessary, right? For this whole analysis, I could have just said S squared acting on S minus S is S plus 1, S minus S. That is the same calculation. Okay, what do you have? Do you see? Any questions?
No, yes, sir. I got it.
Okay.
I'll go through it further.
Yeah, go through it. Okay. Anyone else? Any questions?